What's the problem with that? Mason?
They're all
They're not all the same. One what?
Jay McCumber, please come to the Perry office.
Right, like, how would we call this? Well, and now I'm recording. So there you go. Now I'm recording. So if you want to go back and see what you missed. So, Jay, before you get out of here, this we would call one whole, right? That'd be one whole. What would we call this? This is 1/2. What could we call this? 1/4. What could we call this? 1/8. So guys, the problem is these denominators are not the same. So just like if I tell you, I'm giving one of you 2 and I'm giving one of you 1. But what if the one that I gave 2, I give you 2/5? And the one that I give 1, I give you 1/2, not 1/5, 1/2. Who actually got more here? The 1. Because the denominator is so important. It's telling us what size we're working with. So, to keep reading, sorry, we're losing Jay. Anyone else want to read?
Me. I can read for like a second.
No, you have to lead.
Thanks.
All right. So, Harrison, thank you.
To create common denominators, we perform multiplication at the top and the bottom of the fractions. We
Pause. If I was you, I would grab a highlighter. Multiplication of the top and bottom is both. We're doing both. Goodbye, Jay. TTFN. Top for now. All right, then continue whenever you're ready.
We choose to multiply after thinking the multiples of each denominator.
It's also on your paper. So to get multiples, you multiply, right? 5 times 1, 5 times 2, 5 times 3, 5 times 4, however far you want to go. Then 2 times 1, 2 times 2, 2 times 3, 2 times 4. You are looking for a multiple that is in both lists. Alternatively, you could look at your multiplication table that has all the multiples listed out for you. You're fine, man. So what is the common multiple between 2 and 5? What number do we see in both lists? The 5 list and the 2 list. Concept? 10! 10's our common multiple! You can go ahead. I can talk over that. I know in most other classes they tell you to wait, but I appreciate you being polite. So that 10 is 5 times 2. So that's how we know to do times 2 on top and bottom. This 10 is 2 times what? 5. It's like the 5th multiple, right? So that's how we know to do times 5 on top and bottom to get to that common denominator. You are like suspiciously happy right now.
Yes, my sister taught me this like 3 years ago, and I understood it. And this is the first time any teacher ever brought it up in class.
Shout out to Izzy's sister. I don't even know if I'm in the frame right now, but shout out Izzy's sister.
Best sister.
So if we want to visually, by the way, this right here is talking about these. You don't need to put this in a box, but like this is a fancy one. What did CPM call it? Or maybe your 6th grade teachers did. The giant one, right? Because we're doing the same thing on top and bottom. What that means is we're not actually changing the value. We're changing what numbers we're using, but the value is staying the same. So, let's look at it visually. 2/5, we cut up more. Now we have 4/10. 1/2, we cut up more. Now we have 5/10. Do we now have the same number on bottom? Yeah, 10ths and 10ths, right? So then we set up the actual addition. Once we have the same number on bottom, we keep that same number on bottom. Because think about putting away your leftover pizza. As you're putting the slices together in the same box, the size of the slices doesn't magically change now. We had this much left over, that much left over. How much do we have when we put them together? 9/10 together. So this is your reminder that in your Desmos, you're going to be asked to put some fractions together through addition. But to do that, we need common denominators. You are unpaused.
Yeah.
Now, if you want to have the same work as the person beside you, you gotta choose the same numbers. If you're wanting to work with somebody on the Desmos, you gotta pick the same numbers and like put them in the same place. So I'll give you a few more minutes to play with this before we come back together. But that graph paper was so you have somewhere to write some stuff down. By the way, those of you playing along at home, sorry I forgot to start the recording. Today's not Thursday. How did I get on the wrong slide? How did nobody this morning call me out on this? All right, well, it's Wednesday. Sorry about that. And today is the 23rd. Yeah, Wednesday. The weirdest word. English doesn't make any sense.
It's 23rd. now.
Hey, I might shift this homework a little bit farther. But for sure, addition and subtraction with negative fractions, that is our homework, and we're going to practice it together. Remember, we have a double length class today. We should have time to practice con before you get out of here. All right, take a couple more minutes, try your Desmos. Everybody that has moved past slide 3, except for Asher and Isaac. Good job, guys. But everybody else should go back to slide 3 and check on what you did. And I'm coming around to help if you would like some help. Slide 3 is where we're asked to put those together. You guys were good, though. Your slide 3 was good. So that's why I was saying, except for you guys. I can't remember who had gone past it. So to add these up, we're going to need to first think about a common denominator. Right now our denominator is 1 and 3. We need to find somewhere that they can meet. And we could use this and look through like our list of multiples of 1 and multiples of 3. But really, when we have a small number and a bigger number, we should ask, can the small number become the bigger number? Actually, I think maybe we should practice one of these together before I really am asking you guys to do too much on your own. Let's do one of these together. What? Don't know me. On your paper, down at the bottom left, let's do this first one together. And because we need to do some random cards. Reg came back in perfect time. We're doing one of these problems from our paper together. Kyra, you're not here. Feel better, or whatever has you not at school. Sophie, our denominators that we have in this first problem, are they common right now? No, they're not. Do you think we're going to need to change both numbers or only one of them? Hey, Harrison, what you doing right now is really rude. Sorry, what'd you say, Sophie? So this is one where we actually don't have to change both. Anytime that we have like littler number and bigger number, ask yourself, can the smaller value turn into the bigger value? Our denominators are 3 and 6. Can 3 turn into 6? How? Times by 2. So on your paper, and you can write this right on your handout. You don't need to do graph paper for this one. We're going to show times 2 to turn that into 6, but then if we do it on bottom, we also have to do it on the top. Callum, where are your glasses?
Got them.
Can you see from back there? That was a very long delay. I will believe you when I come around and you don't have whatever written down, you're going to need to move. If you do have it written down, because you can see, totally fine, you got me. Okay? Sol? Well, I don't want the answer. It's all about the process. We'll get to the answer. All right, so this first fraction now becomes, like, what is it now? Monsef, can you help me? What's this fraction turn into? 10, 6, plus, anything happen to this fraction? No. Now that we rad have common denominators, what do we do with that common denominator? Do we add them, or? I maybe should have skipped you because you were out of the room. If we go look back up here at what I think you missed from us going over because you ran to the restroom, once we have common denominator, it comes with us. We don't add the denominator because that's just telling us what the size of the pieces are. We want to add the pieces we have, but not the size of the pieces. So guys, I hope you're writing this down so you get that practice that like the more you write things down, the better it gets into your brain. Once you have a common denominator, keep it. Carry it along with you. You do not add them. So then, Callum, if I have 10 and negative 7 being added, do they get along or do they fight each other?
They fight each other.
And who wins?
The 10,
By how much?
3.
So we get 3/6. Jay's not here. Link, can I do anything else to 3/6 to make it like better? Yeah, this poster has a potty mouth on it, but it's still a pretty decent poster. We want to reduce by just like when we multiplied on top and bottom, except for to reduce, what do? Anybody? Divide top and bottom. What can 3 and 6 both divide by? Anybody? 3. And this turns into 1/2. Questions on that? Let's try one more together just to make sure we're feeling good. 2 and 5. Denominators of 2 and 5. If only we've seen denominators of 2 and 5 somewhere else. Oh wait, that example problem, that's on your paper. So I'm going to skip this middle problem so we don't like crowd up this paper too much. Guys, let's look right at this one. Our denominators of 2 and 5 are on the example. Like the done example in the boxes. What is a common multiple 2 and 5 can both get to? 10, right? So now I'm going back to cards. So Anna, what do I want to do with 5? Sorry, what do I want to do? Okay, no, I'm going to keep my question what it was. What do I want to do with 5 to turn it into 10? Boom. 5 times 2. And since we do it on the bottom, we also have to do it on the top. So we're not actually changing value. We're just changing numbers. Link, you writing this down with me? It's the third one over. I'm skipping that middle one just because it's kind of... I put too many questions on here. It's just too close. What, Asher, do we need to do to 2 to get it to 10? Times 5. And if I do it on bottom, I got to do it on top. All right, so now we turn into... Ooh, you want to keep going? What's this fraction turn into? Ooh, it said the other way around. 15 tenths, right? Because we get 15 on top. Plus... Ooh, this is why I wanted to go over this problem. When you have a negative involved in a fraction, guys, this is just begging to be forgotten about. Because this negative and this fraction bar are right on the same level, you're allowed to move that negative into the numerator or into the denominator. It does not go to both places, because what's a negative divided by a negative? Positive. We don't want positive. So we should really write this as negative on top. What's 6 times 2? 6 times 2. And the 5 times 2, we know what we're getting because that's what our goal was. Isaac B, what do I do now that I have a common denominator?
You add together the two fractions.
We add together the numerators. Do I add the denominators or keep it? Keep the denominator. Add the numerators. Do they get along or do they fight?
Fight.
They fight. 15, 12, who wins? 15 by 3, excuse me. And we cannot reduce this because 3 can only divide by 3. Can 10 divide by 3 nicely? No, not nicely, right? So we get 3 tenths there.
Only nice numbers.
Yeah, I mean, when we're reducing, we only want to think about like nice numbers and nice options. All right, I'll give you a couple more minutes. If you want help with what you're doing on the Desmos, please call me over. I know in the morning I have like a second teacher in here, so I'm a bit more free to help. But you are trying to practice, and you could write it on your paper if you want. Make common denominators, and then put those fractions together. You guys will also have the opportunity to earn a sucker during class here in a little while after we take our break. Just say, it's been days since I've handed out candy, like probably a couple weeks actually. You know, trick or treats coming up. And I know, and that was for winning. Right now, though, you guys are not winning LearnStorm, just to put it out there. I mean, we still need to check for today, but right now you're not winning. Isaac K., you need to go back to slide 3, man. I don't know how you jumped your way all the way to 7. Yeah, we're still working on the Desmos right now. Like, no one's even close to done. Mason, we should go back to slide 3 together. Harrison, I can't find you in this moment. No, you're still on slide 3, so I can't see if you got it right or not until you move on. Click next, and then it'll tell you did not get it correct. Go back and reevaluate whatever you did. So, no, you can do that. You can do that. We're just on slide 3 right now. Okay, sweet. So, can the 1 turn into a 3? Or do we need to change those denominators? Yeah, so if we multiply by 3 on the bottom, we also need to go on the top. We could write this down. We want to keep track of things. But what is that? So then we're going to have 6 thirds plus 6 thirds. What's 6 thirds plus 6 thirds? Yeah. So keep erasing back. I'm curious why it's saying that. Oh, this one is saying change your numbers. Because I thought you were still on maybe it was slide 2 where you were adding fractions. Make sure you read the instructions, because that was my issue, is I didn't read those instructions. So no offense to Desmos, because I love Desmos, but a little bit more important is making sure that we have some things written down to look back at. By the way, sorry for eating a cookie in front of you guys, but I might go crazy if I don't put a little bit of sugar in me because it's been a rough morning. Let's do... Everyone grab your graph paper. Yeah, be mad at me. I don't care. All right, so we're going to do these 2 problems. I want you to, like, you might want to write this on your graph paper to have space. If you do it on your handout, that's okay. There's some space. I left you a little bit. So the first thing we need to be thinking through is common denominators. Then what do we multiply by? And then actually put them together. So I want you guys to get a head start on me. Start trying to solve this negative 5/8 plus negative 8. Oh, that's fun. They just kind of flipped them over. This one's 5/8. This one's 8/8. That's kind of fun. So I should see you writing things on paper as I'm walking around. This you could chat with your partner about because you're looking at the same problem.
Which one?
The middle one. The 5/8, 8/5.
Wait, what?
On the back.
Oh, you said graph paper.
No, I said you could use this. This one's what we're starting. Okay, middle one on the back. So that middle one on the back. So it is on your hand. You can see it. 8 and 5. We gotta find common multiple for 8 and 5. And if you're realizing, like, wait a minute, I can just do... Yeah, that does always work. And I want to know if anyone has figured out, wait, I could just do that, and that, do that. And it'll always get you a common denominator. Anyone know what I'm talking about? We just did it with the 2 and the 5. A lot of hands went up at the same time. I want to give some credit to Izzy's sister. So, Izzy, do you know what I'm referring to?
I think so. You can just multiply each one by their denominators. Like you can time if we were doing like the -5/8 plus -8/5, then you could just times 5/8 top and bottom by 5, and then -8/5 by 8.
Hey, stop what you're doing and hear what Izzy just said. If we have a denominator that we're trying to make common with each other, just grab the other denominator and multiply by it. Because if we swap around the denominators, like, here's what I mean. This 8, what do we want to multiply it by, Izzy?
We're gonna multiply that 8 by the top of. Sorry, we're gonna multiply that 8 by the top. Oh wait, sorry. Okay, no, I got confused my answer. We times both of those by 5.
If you want a trick, I'm not saying this is the easiest way. It's just a way that works. Sometimes it is the easiest. Guys, think about this. My multiples of 8. We should really turn this off before I walk away from my desk. 8, 16, 24, 32, 40. And if I list out my multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40. So that ... means like stuff keeps going in between. Like that's literally how math uses ... We find our way to 40, but what 40 is 8 times 5 and 5 times 8. So a trick that always works, if you don't want to think, if you don't want to have to look at your multiplication table, you can literally just say, I'm going to do this over there, and I'm going to do this over there. So what we're doing here is times 5 times 5 and times 8 times 8. Now I need your help because math is hard. We know we're getting 40s on the bottom. What is 5 times 5? Is what I have written down right now correct? Negative. This negative is begging to be left behind. Like the podcast I listened to where a girl's family, they were RV camping and they left her at a gas station. Not joking. If everyone thinks you're asleep in the top bunk and they just, drive off and you decided to go to the restroom and not tell anyone, you're begging to be left behind. That negative blends in with the fraction bar and it's way out front. This negative being in parentheses, I hope we don't forget about that guy. But what's 8 times 8?
64.
64? Do the Macarena. Isaac K. Now that I have a common denominator, what do I do with it? With the denominator stays. Guys, I like to think about the denominator before I think about the numerator. Just so it's already done, out of the way. Once I do the math, I'm literally done. So then positive, negative, do we get along or fight?
Get along.
I was testing to see who's going to actually be paying attention.
Oh,
Did I fix the thing Monsef told me I needed to fix? No, this is actually also negative. Guys, I'm telling you, put your negatives in the numerator. Don't put them out front. Put them in the numerator. So now, do they get along or fight? They get along. They're going to make big bad guy. All right, what is it? Negative
89.
89.
And to simplify, -2 and 9 40ths.
Well, okay, we can make it back into mixed, and that's fine. Could we reduce this? Because I think Con will let me put in improper fractions. I don't think because
Unless it specifically says
89 is a
reduce,
funky number.
then it lets us.
89 is a funky one. 4 can divide by 2, or like 4D could divide by 2, could divide by 4, could divide by 5, could divide by 10. None of those help me here. 89 feels like it's.
I'm sorry, I have a funky bracelet. You
Oh,
have funky
I dig your bracelets. I just thought you were trying to like get my attention.
No, I'm sorry. I got
Let's do one more to make sure we're feeling good. Try this one on your own. That one's actually easier. Try the final one on the right at the back of your paper. Try that one on your own. Well, or with a partner. I just mean without me. Try that one without me.
Wait, which one?
On the back, on the right. Great. We just did this one.
Oh, I already did that, so I'm good.
Flex.
I want to say,
Okay.
I can see the
Okay.
I cannot
Read what?
Yeah, I
The
know.
poster or what?
I cannot read it in the post.
Can you read the words on the board? Like the typed words. Because I know I write kind of big.
Wait, Mr. Hudson.
I'm just curious. I'm not gonna make you read it.
It's hard for me to read words. It's really easy for me to read numbers.
Well, and especially because how I write, I try to make things really contrasting, like light color on dark color, right? But
Yeah, 5.
just make sure that if you are struggling to see, if you move yourself, because it's bad for your eyes to strain. Like your eyes will get worse if you don't wear your glasses and you put your eyes under strain. They only get worse.
These ones actually block.
Yeah, we got double time.
And I'm
So here in a few minutes we're gonna take a break. Well, we're gonna come back. I don't know. We're gonna come back.
Yes.
So I thought you had your hand up, but I think it's just how you were sitting. It made me feel like you had your hand up. Harrison, do we have common denominators right now?
No.
No. So what do you want to change? Both or one of them?
One.
Because we don't actually.
Hey, we're coming back together. I know you might not be totally done, but I just wanted you to get a head start because that's the hardest part of the process. Harrison, say again.
We only need to do one
Why is that?
because 12 is one of its.
Oh, hey.
multiples.
When one of the denominators is a multiple of the other, we do not have to change both. Hey, look up here real quick. The trick I just showed you, you could times 3 times 3 times 12 times. You could. Do we need to do that here? No. All we need to do is change the 3. That trick is unnecessary. What do I want to multiply the 3 by? You can walk those wheels, by the way. Times 4. And we do it on top also. Any questions on why we just decided to multiply by 4 on top and bottom? So now we just, what should I do with the negative 5/12? I should write it negative 5 over 12, right? Put the negative on top, make your life easier. Ooh, there should be an alarm going off in your head. Mason, why is there an alarm going off in your head?
When there's like a negative being minus by negative, they both become positive.
Minus a negative actually becomes plus positive. So this really turns into addition. That negative's gone because it got used. So, like in my brain, I'm still thinking put the negative on top, but there's no negative. It's gone. We used it. You might want to notate to remind yourself, hey, that minus negative became plus positive. Ooh, 9 times 4.
Wait, does that mean that 5 still has a. Yeah.
Yeah, 5 is still negative.
Emma Bruchette, please come to the Perry office for dismissal. Emma Bruchette, please come to the Perry office.
Now that the denominators are common, keep it, right? Now that the denominators are common, keep it. Soul. Yeah, so they fight. Our good guy wins. We get 31 over.
Or positive is good and
Like
negative
it's
is
the
bad.
same. Like if you just multiply by each other, you get the difference.
You want to say it again? Or you want me to say it again?
Like
Hey, hold up. Hear what Mason just said.
basically, if you just do the same technique where you like multiply 3 with the
Like,
first one
Times 3s, times 12s.
you'll get the same answer. It's just you just have to divide it against by 3 and have it.
It's like taking the longer way home, right? Like Mason's saying, we get to the same answer. So that trick I said you don't need to do, you're very distracting to me right now. That trick I said you don't need to do, you can. No problem with doing it. It just takes a bit longer. It's like the long way home. Everybody else is about to be switching classes. You guys can go take a break, up to 5 minutes. I need you back here by 3:10. It'd be better if, as like other kids are going into classrooms, you come back here because, like, their classes are all releasing right now, and they should be in their next class 3 minutes from now, right? So also, if the bathroom's really crowded or whatever, let them go first because you can have up to 5 minutes. But you can go take a break if you need to get a drink, use the restroom, whatever. Go take a break. We're coming back here though because we have double block of math today.
Let's go.
Let's go. Put it on the board and have us do it together. So all of us should be switching from Desmos. You can leave Desmos open and work on it later if you really want. But I'd rather us do the Khan Academy that gives you instant feedback. Because what I love about Desmos is it doesn't tell you, like, you're wrong. I mean, sometimes it does. But, like, that's good when we're learning. Now that we've learned what we were trying to learn, let's apply it. Let's do it. Let's show that we know what we're doing. So, Rad, switch over to the adding and subtracting negative fractions assignment. Also, because you and I can just talk about your mistakes on it. If you want to retake it on your own, you can. Or you and I could just discuss mistakes. Link, you finding it? Mason, you finding it? Adding and subtracting negative fractions. Because there's also rational numbers. So make sure you're doing the fraction one. Sophie, we're doing the fraction assignment right now. So leave the absolute value for just like in a bit. I just want us to do this right now while it's fresh on our head. I don't know what happened to Monsef, but he has disappeared from my class. Sorry, Monsef. Apparently you got kicked out of the class.
What?
You got kicked. You're expelled. That's how you find out that you're expelled.
Yeah. You can't open Khan Academy.
There you are. All I had to do was refresh. Don't worry, Monsef. I guess we'll keep you here for today.
Monsef has to go back to not tomorrow.
Not McCord.
Would Hannah Schaefer please report to the Perry main office for dismissal?
Hannah.
Hannah Schaefer to the Perry main office for dismissal,
What did
please.
she do this time?
It's always the same kids every day.
Yeah, I swear. What do they keep doing?
They're dying. They're dying, and then their ghosts are coming back, finding their remains, possessing them, and then going back
Would you
to
be happier if I posted a multiplication chart to Schoology?
Yeah.
Okay. I just wanted to offer because I can.
Didn't you? No,
I
never
don't
mind.
know.
That was a different thing.
All right. If you have a problem that's way too hard, please ask me for help. Then I might put it on the board. But if you have not written anything down, I will not help you. Because that's the first step of help is write it down. Because literally that's the first step to helping yourself. Is write it down. But just like in Foundations, which you guys did awesome in Foundations, at least over on this side, you're not looking at the exact same problems as your partners now, or your classmates. So I don't think we need to be talking. And just to show you guys, Schoology changed a little bit, like my Schoology. So look up here real fast. I really don't want to lock your computers. I don't know if you can read this from back there. Why is this joke funny? What's it say, Harrison? Read it for us.
That's impossible. I can't have a negative blood type.
And why does that make it funny?
Like, absolute value. You can't have
Yeah, it's gonna become positive because the absolute value of anything is going, and it's coming out of the absolute value, right? The blood would be coming out, so like that's impossible. This can't be negative. It came out of absolute value. All right,
What
but that's
is
not.
negative?
I didn't make you come look over here to see the bad pun. What I made you come over here to see is notice that this folder, guys, I am making less notes for you because I realize people are just leaving them on the desk. They're leaving them in the family room on the floor. Like, most of you aren't using the printed notes like you should be. And, like, I'm still going to keep pushing you to use printed notes. But I decided I needed to click into here for more materials so that you actually realize this is not just a picture. It is a folder that then has our absolute value PDF, a couple, these are just pictures. If you click in, it's just a picture. But then this video, if you're struggling on last night's homework, I'd probably speed it up. But real great help video right here. But then if I go back, what we're doing now, adding and subtracting with fractions, here's an example done out right there. But then we can click into the folder. And there is more stuff, and I will continue to post more stuff. Here's the handout from today, right? So, like, we're using Schoology kind of like where to find our notes. So just realize, like, things have changed a little bit. This guy's got some pretty good videos. Math with Mr. J is, like, pretty solid stuff. Yeah. He locks in. I don't know. But alright, Schoology changed a bit. Click into those folders. Check out what's inside of them. Yes.
Does he curse?
No. Well, I don't know. I haven't, double checked for the E word, but I think Math Antics tends to say the E word more because he's trying to make it sound like math is less scary. I'm like, I don't want you guys to think math is scary, but it's tough. It takes hard work.
It's a month.
Yes.
I didn't know if my son typed it well.
Yeah, you're good, man.
Being taught bad.
Hey, so here's your chance to earn a sucker. I made this offer to 1A. They failed twice. We'll see if you guys can do better. Yeah, 1A, if anyone's watching this video, you did not do a great job this morning. 5 minutes of no talking. Just locking in, working.
You can do that. I feel like
Isaac?
you can do that.
What if you like have to use the bathroom or you have to ask them?
Well, one, you don't have to ask to use the bathroom for me. If it's like, if we're just working, you can just go,
What
right?
if,
Because
like-
I respect you and your bladder and your needs.
What if like
I'm only going to say no. I'll never say no. I'll say, give me, wait a minute if you can, if I'm in the middle of teaching. But, blanket, if you need to go to the bathroom, go. But we just took a break, so I hope you don't need to. And if you're coming to talk to me, that doesn't count. I just mean, no talking to each other. I want you guys to, lock in, try to take what we just used, apply it. Do you think we can do it?
I think we can do it.
Okay, what do you need? Alright, 5 minute challenge starting now. Actually, if no one's plugged into this. When you get the fraction assignment done, me talking doesn't count either. When you get the fraction assignment done, here's your priority list.